Welcome to this video. On this video, we're going to do some questions on trigonometry. These are from tutorial sheet 5 under trigonometry. Okay, so before we start answering, I'll just highlight some points which we'll do uh, in order to answer some of these questions. Okay, first of all, I'll talk about spatial angles. Okay, spatial angles. Okay, we have some spatial angles which are 30 degrees, 60 degrees, 90 degrees, and 0 degrees. Okay, these are the important ones which we'll consider. Okay, so um, we start first with 30 and 60. Okay, let's consider an equilateral triangle. So an equilateral triangle is a triangle which has all the sides which are equal. Okay, so let's say we have this side 2, 2, and 2. So an equilateral triangle, it has sides which are equal. So which means all the angles inside should also be equal. We know that a triangle is a polygon which has three sides. Then to find we should note that a triangle should have the interior angles of a triangle should add up to 180 degrees. Then we have three sides, 1, 2, 3. So which means each angle is 60 degrees. So there 60 degrees, and here 60 degrees. Okay, so suppose we divide the triangle there, we bisect it. So when we bisect it there, so which means the bisector there will meet this side at 90 degrees. Okay, and this side will be divided into two halves. So there, from here to here, 1, from the center there to there, 1. Okay, let's now consider just the half of this triangle. Okay, so it has there 2, there 1, there 60 degrees, and there 30 degrees. Okay, 30 degrees. By Pythagoras theorem, we can find this angle which is not included there, this unknown side. So let's say it's x. Okay, and by Pythagoras theorem, we know that hypotenuse squared is equal to adjacent squared plus opposite squared. So in this case, the hypotenuse is 2 squared, and adjacent we can take as 1 if we consider the angle 60 degrees squared plus the opposite x squared. So 2 squared is 4 equal to 1 squared 1 plus x squared. Let's now find the value of x. We can take 1 across an equal sign. So when it crosses an equal sign, it becomes negative. So 4 minus 1 equal to x squared. Okay, so x squared equal to 4 or equal to 3 when we subtract. When we subtract there, we have 3 instead of 4. Okay, then square root both sides, square root, so x is equal to the root of 3. Okay, the root of 3. So there, where we have x, let's put the root of 3. Okay, so there we have root 3. Then here we have 30 degrees. Okay, so we have 30 degrees. So from this triangle there, we can make cosine ratio tan ratio and sine ratio. Let's now start with sine. So we know that sine theta is equal to opposite over hypotenuse. Let's consider 30 degrees. So by considering 30 degrees, so the opposite is 1. So the opposite is 1 and the hypotenuse is 2. So which means sine 30 is equal to 1 over 2. Let's consider sine 60 degrees. So sine 60 degrees equal to, so sine 60, so considering this 60 degrees there, its opposite is root of 3. Root of 3 over the hypotenuse is 2. Okay, hypotenuse is 2. Then let's consider now the cosine ratio. So cosine theta is equal to adjacent over hypotenuse. So taking cos 30 degrees, we have, so when we take cos 30, the adjacent is the root of 3. Root of 3, then the hypotenuse is 2. Then taking cos 60 degrees, we have, so taking cos 60, the adjacent will be 1, then the hypotenuse is, the hypotenuse is 2. Okay, okay, now let's consider now the tangent, which is the tan. So tan theta is opposite over adjacent. So tan, let's take tan 30 degrees. So tan 30, considering 30, the opposite is 1, then the adjacent is root of 3. So that means tan 30 is equal to 1 over root 3. Okay, then tan 60 degrees is equal to, so tan 60, considering tan 60, its opposite is root of 3, then adjacent is 1. So therefore tan 60 is just the root of 3. Okay, it's just the root of 3. Okay, so we have now dealt with 30 degrees and 60 degrees. Okay, let's consider another situation where we have a triangle. Okay, we have a triangle which has two sides which are equal, only two sides which are equal, not the hypotenuse but the opposite and the adjacent. So there we have, let's say we have one there and one there. So if these sides are equal and there we have 90 degrees there, where there is a right angle there, it's 90 degrees, so which means this side is equal to that side, and this triangle should add up to 180. So 90 plus these angles should give 180. So which means this angle and that angle also add up to 180, add up to 90, so that when we add with the right angle it makes 90 degrees, which means this side is 45 degrees. So this is 45 degrees and also that is 45 degrees. When you say 45 plus 45 plus the right angle, it makes 90 degrees. Okay, then it makes 90. So 45 plus 90, 180, making up the sum of a triangle. Okay, let's find this side, the hypotenuse. Okay, so in this case, hypotenuse squared, considering Pythagoras theorem, will be opposite 1 squared plus 1 squared. So h squared is equal to 1 squared, 1 squared, 1. So 1 plus 1, 2. Then we square root on both sides. We square root on both sides. So h is equal to the root of 2. So there, the hypotenuse is the root of 2. Yes, the root of 2. Okay, so know that that is the root of 2. Okay, the root of 2. Now let's from this we can find the angles. Now we can find the sine ratio considering the angle 45. Okay, I forgot to include there 45 degrees. It's also part of the special angles. Okay, so let's start with the sine. So sine 45. So we know that sine theta is equal to opposite over hypotenuse. So you can see that there are 45 and there are 45. So you can take any. So considering this, so which means the opposite is this, then the hypotenuse is the root of 2. Say so the opposite in this case is 1, then the hypotenuse is the root of 2. Okay, that is sine 45 degrees is equal to 1 over root of 2. Let's now take cos 45. So we know that cosine ratio is equal to adjacent over hypotenuse. Also considering that side we took at first, the adjacent in this case is 1, then the hypotenuse is the root of 2. So cosine 45 is equal to 1 over root 2. Now what of tan ratio? So tan theta in this case 45 is equal to opposite over hypotenuse. So the opposite is 1, then the adjacent is also 1. So 1 over 1 gives 1. So that is tan 45. Okay, that is tan 45. So far we have talked about 30 degrees, 60 degrees, and 45 degrees. Let's now consider 0 degrees and 90 degrees. Okay, so now consider this and that. Okay, to consider this, let's take the graph for each of these. So we have graph for sine and graph for cos. So let's consider first the graph for sine theta. So let's say y equal to sine theta. Okay, so then there are 0, 90, 180, 270, then 360. Okay, so the graph for sine starts at 0, then it goes up and passes through 180. Then to make a complete revolution, it ends at 360. Okay, so there we have the amplitude 1, then there -1. Okay, so when we say sine 0, let's start sine 0. Sine 0 degrees is equal to, so sine 0 there it's corresponding to 0. So the sine of 0 is 0 degrees. Then let's take sine 90. Sine 90. So sine 90. So the sine there is 90 there is corresponding to 1 on the y-axis. So there of theta on the y-axis. So that means the sine of 90 is 1. Okay, so that's the sine. We can also talk about 180, 270, and 360, but for now we're just talking about this 90 and 0. So that's for sine. Let's now consider another graph. We consider another graph for cosine. Okay, we now consider the cosine graph. Okay, let's make it straight. Looks very well presented. So there we draw a line. Okay, so consider the angles there. We have 90, 180, 270, and then 360. Okay, please bear with me, the handwriting is not that much, but I hope you're understanding what I'm doing. Okay, so then there we have the amplitude 1 and also -1. Okay, so the graph for cosine starts at 1, then it passes through 90, then 270, then it ends there at 360. So there. Okay, if we consider in the range from 0 degrees to 360. Okay, from this graph let's find sine 0 or cosine 0. Sorry, cosine 0. Okay, so cos 0, so when you go in the x-axis, 0 is corresponding to 1 on the y-axis, so that means cos 0 is 1. Okay, what of sine, what of cosine, what of cosine 90? Cosine 90, so 90 there is corresponding to 0, so it's 0. So you have seen that this is in this case the cosine graph is the opposite of the sine graph. In the sine 0 is 0, then the cosine 0 is 1, and sine 90 1, cosine 90 0. Okay, having this knowledge on special angles, we can now solve question A, part question A of this question 8 of the tutorial sheet. Yes, so make sure you understand all these concepts in order to answer question A of this question 8 of the tutorial sheet. Okay, let's now do question A. Okay, so question A reads 2 cos 3x equal to 1. So 3x is the whole angle. Okay, so in order to answer this, you can say let 3x equal to theta. Then where there's 3x, we substitute theta. So 2 cos theta is equal to 1. And divide by 2 on both sides of the expression, you can say, or can say the equation. So theta equal to 1 over 2. Okay, first of all, you should not find theta directly. You can say, you can find, let's say, just the included angle. Let's say theta, you say in this case cosine, not theta, but say cosine alpha equal to half. So alpha is equal to cosine 1 over 2. Okay, so I stated from the special angles. So the special angles, we have the cosine, which gives half. So okay, let's consider the triangle again. Okay, so there we have then 60. So there it is the root of 3, and there 2, and there 1. So which means in this case the cosine 60 is the one which will give 1 over 2. So cos 60 is equal to 1 over 2. So there cos alpha equal to 1 over 2. So which means the alpha there is 60 degrees. Cosine there is 60 degrees. Okay, so we know that theta there was positive, so which means one of the angles is also 60, but we should also take into consideration the quadrants. So we have quadrants, so we have there 0, 90, 90, then there 180, 270, then to make a complete revolution 360. So this is the first quadrant, second, third, then fourth. Okay, so the angle we have found is lying in this region in the first quadrant, so that is the 60 we want to find. So let's now find the other angle where cosine is positive. So in the first quadrant, all angles are positive, then in the second only sine, in the third only tan, then in the fourth only cos. So you can remember this by just making a memory aid whereby you say all students take chemistry, or if you want all students, okay, just say that all students take chemistry, or others say all students take chibuku, but it's not chibuku is not good for healthy. Yeah, alcohol is bad. Okay, we continue. So in the third quadrant, um in the fourth quadrant, we have seen that the angles are not exceeding 360, so you can just make an expression whereby we say theta is equal to 360 degrees minus alpha. So theta is equal to 360 minus 60. So theta in this case is equal to 300. Then this is in the fourth quadrant. Fourth quadrant, you can just abbreviate it as quad. And in the first quadrant, that angle you find alpha is equal to the theta, so theta is equal to alpha, therefore theta is equal to 60 degrees. Okay, so we have now found that theta is equal to 300. It's also equal to 60 degrees in the first and fourth quadrant. Okay, in the first and fourth quadrant. But let's go back to the question. We are taught to find x and not theta. Okay, and not theta. So we say now when theta is equal to 300 degrees, when theta is equal to 300, so we substitute where we said 3x is equal to theta. So where there is theta we put 300, then 300. Okay, we divide by 3, so x is equal to 100 degrees. Then 3x when theta is equal to 60, so therefore x will be, where there is theta we put 60, then we divide by 3, so x is equal to 20 degrees. Therefore x is equal to 100 degrees, 20 degrees. So those are the angles. So by doing all that I've done, then you have answered the question part A. Okay, let's now go to part C of the question. Okay, so before we do part C of the question, I can talk about just some of the identities involved in this. Okay, so we have the sine ratio, so the sine, tan, and the cosine. Okay, we should note that tan theta, or tan x in this case, is equal to sine x over cos x. So sine x, tan x is equal to sine x over cos x. Okay, so I think this is enough on this question. Just take note of that. So let's now consider that. So we use the data we have analyzed there to answer this question. So you know that tan x is equal to sine x over cosine x. Okay, let's now answer part C of the question. Okay, so we are given 2 sine x tan x minus tan x equal to 1 minus 2 sine x. Okay, so from this question, I think the best method that we can use there, we can first factorize tan x. So I've seen on the left hand side of the equation that tan x is common there. By common factorization, we factorize tan x. So tan x, open bracket, 2 sine x minus, so while there's tan there, just remain with 1 since there is nothing else that we only had tan there. When we factorize, we remain with 1 equal to, and on this other side we can factorize -1. So we factorize -1, so there we remain with -1 plus 2 sine x, so that when we say we want to expand that, to just bring 1 minus 2 sine x, so that we have -1 multiplied by -1, we get 1, then -1 times 2 sine x, we get minus 2 sine x. Okay, so tan x, open bracket, 2 sine x minus 1 equal to -1, then you can write this as 2 sine x minus 1. Okay, so we have seen that 2 sine x minus 1 is common on both sides of the equation, so we can divide throughout by this so that we eliminate it. So 2 sine x minus 1, even here 2 sine x minus 1. Okay, so this and that cancels, this and that cancels, so tan x is equal to -1. Okay, then here you say you first find the included angle, which is tan theta. So tan theta equal to, and you consider it first as positive, then afterwards you come take into considerations the quadrants, so you take it as positive. So from the special angles, we made at first this situation of a triangle whereby we add there 45 degrees, also there 45 degrees, and there we add root of 2 and 1 and 1. So from this we found that tan 45 is equal to 1, so the opposite there, then adjacent there, so tan 45 is equal to opposite 1 over adjacent 1, giving us 1. Okay, so from this we can say tan inverse 1 so is equal to 45 degrees. So tan inverse is equal to 45 degrees. Tan inverse is equal to 45. Tan inverse of 1 is equal to 45 degrees. Okay, let's now take into consideration the quadrant, because there we add -1 and not +1. Okay, so all students take chemistry. So there are 0, 90, 180, 270, then 360 degrees. Okay, so yes, so there we are the negative. So let's consider the quadrants where tan is negative. So tan is negative in the second and the fourth quadrant. So the angle lies there and there. Then the angle we have found is there, so we have there 45 degrees. So we need to find this angle and that angle up to here. Okay, let's now find that angle. So we find those angles. Okay, so let's start with the second quadrant. So second quadrant, so in the second quadrant the angle should not exceed 180 degrees. That means x is equal to 180 degrees minus alpha. So x is equal to 180 degrees minus 45 degrees. So I guess that will give us 135 degrees. Yes, from the second quadrant. Okay, let's now go to the let me first create some space. Okay, create some space. Okay, there. I hope it was clear there. Okay, now the third quadrant, or the fourth, sorry, the fourth. So fourth quad. So the fourth quadrant. Okay, so from the fourth quadrant, the angle should not exceed 360. So that means x is equal to 360 degrees minus alpha. So x is equal to 360 degrees minus 45. So when you subtract 45 from 360, you are having 315 degrees. Therefore x is equal to x is equal to 315 degrees, and 315 degrees and 135. Okay, so those are the angles. Okay, I hope it's clear. Okay, so that's how you do this question. Okay, let's now do part E of the question. Part E of the question, which was 7 sine 2x plus 30 degrees equal to 3 cosine 2x plus 30 degrees. Okay, even here we have seen that we have sine 7 sine 2x plus 30 degrees equal to 3 cosine 2x plus 30 degrees. So we have seen that 2x plus 30 is the angle, and there 2x plus 30 degrees is also the angle. Since it's common on both sides, you can just say, instead of starting expanding, you can say let this O angle equal to, you say maybe theta or alpha or y, anything you like, but me I like theta. Okay, so we have 7 sine theta equal to 3 cos theta. Yeah, 3 cos theta. Okay, so I'm sure earlier I made the statement that tan x, or in this case tan theta, is equal to sine theta over cosine theta. So when you have two functions in one equation, in this case we have sine and cos, it's better you make one function. In this case you can make tan, okay. So there, so to make tan you can divide throughout by cos theta, even there cos theta. Okay, so there, this and that cancels out, and there I have 7. So sine over cos, that is tan theta, equal to 3. Then we divide by 7, so tan theta is equal to 3 over 7. I'm sure someone is surprised here, thinking that we have made a mistake because we are not getting something relating to special angles. So in this case, this is just a tutorial sheet. In this question, you should there must be use of a calculator, so you can find tan inverse of 3 over 7 using a calculator. So you can say tan inverse tan inverse 3 over 7. Okay, so using a calculator you can find this. So we say tan inverse 3 over 7. So me, I'm getting 23.2. I'm getting 23.2 degrees. So that's the angle there, theta. Right. Let's now go back to the question. We are told to find x. So since there we are in the angle we have x, so we should find x and not theta. So okay, before that we should also take into consideration the quadrant. So tan is in this case was positive, so we can consider the third quadrant. So tan is positive in the third quadrant. So in the third quadrant the angle is more than 180 degrees. Okay, what I mean is this. So this is the third quadrant. So there I have 180 and there I have 270. Okay, then we have that angle we have found is 23.2. We are finding this angle. Okay, we are finding this angle. So to find that angle, so we know that from here up to here is 180. So and this angle is equal to that angle. So which means you just say 180 degrees plus that angle, or you can just consider it as saying that angle is exceeding is more than 180 degrees. So just say that's 23.2 plus 180. So when you add 23 plus 23.2 plus 180, you get 203.2. So that the other angle is 203.2 degrees. Okay, so then we say when theta is equal to 23.2 degrees, x will be, so 2x plus 3 plus 30 degrees equal to 23.2. Okay, so in this case when we take theta close and equal sign we get a negative, but take note that in this question we are given a range of 0 degrees to 360 degrees, so it is not including the negative. So we discard the negative and just consider the positive. Just consider positive. Okay, just consider the positive. So considering the positive, let's try 203 to see what we get. Okay, so suppose you are the range was including a negative, you can go ahead, take 30 degrees and across an equal sign, then divide by 2. You get something like, so let's say you take 30 across an equal sign, so 23.2 minus 30, then you divide by 2. Yeah, I'm getting something like negative 3.2 degrees. So but this is not in the range, so just consider 203.2. So okay, 203.2. Let's consider now 203.2. So when theta is equal to 203.2 degrees, so 2x plus 30 degrees is equal to 203.2 degrees. So 2x is equal to 203.2 minus 30, then divide by 2 and divide by 2. So x will be equal to, so 203.2 minus 30 and divide by 2, and you get 86.6. okay, 86.6 degrees. So that's how you go about this question. Okay, so we're now done on this question. It has been your presenter, the organic tutor. Okay, thank you for watching. Follow for more videos on mathematics. We have started powerfully on mathematics. Make sure you subscribe. Thank you.